Hello, this is Tracy. Welcome back, Math 135, and we are in section 4.3, the binomial distribution. So in this section, we're going to identify binomial experiments, and with those experiments, calculate the mean, which is also known as the expected value, and the standard deviation. We're also going to calculate some probabilities. So the last couple pages of these notes we'll be using our calculator to calculate some probabilities. And the practice problems from your textbook are listed here. So first of all, we want to identify binomial experiments, and then we'll calculate the mean and standard deviation. So a binomial distribution is a special kind of discrete probability distribution. Remember, discrete. We are talking about things that we can count, not things that we measure. So a discrete probability distribution and a binomial distribution describes a binomial experiment. And here are the three characteristics of a binomial experiment. First of all, we conduct a fixed number of trials, and n is the number of trials. Now, our trials can be the number of subjects that we have in a study that we sample from, and it also can be the number of times we do something. Our random variable x is the number of successes obtained in these n trials. In a binomial experiment, we only have two outcomes for each trial. Each trial is either a success or a failure. P is the probability of success, and Q is the probability of failure. Now keep in mind, because our random variable is the number of successes, success is just whatever it is we're trying to count. Success doesn't mean a good thing necessarily. A success could be a heart attack. A success could be needs a heart valve replacement. A success could be died during the course of our study. A success is just the outcome that we are counting. It doesn't necessarily mean a good thing. Sometimes it's better to fail in these experiments. So P is the probability of success. Q is the probability of failure. Since these are our only two outcomes, these are complementary events. You succeed or you don't. So the probability of success plus the probability of not succeeding, well, the probability of complementary events always sums to 1. The n trials, this is the third characteristic of a binomial experiment, the n trials are independent and they are repeated using identical conditions. So if we have these three characteristics, we have a binomial experiment, and that's what we're going to look at soon, whether or not we have binomial experiment. In the meantime, we're going to talk about some of the calculations and notations that we use. The expected value, or the mean, of a binomial distribution actually makes a lot of sense if you think about it. Mu is the mean or expected value for our binomial distribution because it's theoretical. This isn't from a sample, so it's not the x bar. Our expected value, the expected number of successes, is the number of trials times the probability of success on each trial. Mu equals n times p. Now the standard deviation, this is one of the things that you will have given to you in your notes sheet. You just need to be able to use it. Sigma is equal to the square root of the number of trials times the probability of success times Q. You just need to be able to pop that into your calculator and get the correct standard deviation out. So for notation, we use this notation here, x, and then that little squiggle, tilde, I can't remember what that's called, x, that little squiggle, capital B, and then parentheses n comma p, means that x is a random variable with a binomial distribution. X counts the number of successes. The little x can take on the values, well, if you have n trials, you could have no successes in those n trials. You could have 1 success, 2 success, 3 successes, all the way up till n, the number of trials. All of your trials could be a success. So those are the values your random variable can take on. The experiment has n trials, and the probability of success on each trial is p. And these n and p, these are what we call our parameters. They just kind of define our binomial distribution, and they'll be important because we need those to plug it into the calculator and get out correct values. So we are going to look at the experiment and decide if it's a binomial experiment, and if so, we're going to write down all the stuff we saw on the last page. And then we are also going to give the proper notation for the question at the end. What is the correct notation for the probability of tossing fewer than 12 heads? We're not going to calculate this yet. We'll do that later on in this lecture. So, our experiment, we toss a coin 100 times and count the number of heads. Is this binomial? Well, we need to ask, does it meet the 3 criteria for a binomial experiment? Number 1, fixed number of trials. Does this experiment have a fixed number of trials? How many times do we do whatever it is we're doing? Yeah, it's got a fixed number of trials because our n, our number of trials, is 100. It tells us that. Flip a coin 100 times, fixed number of trials. 2, we need to have 2 outcomes. And those outcomes would be success and failure. So if we are flipping a coin and counting the number of heads, well, what outcomes are we looking at? In this case, a success would be heads, and a failure would be tails. These are our only 2 outcomes, heads and tails. So, yes, we meet that criteria for a binomial experiment. Number 3, our trials are independent. And what do we know about fair coins? Fair coins, you always have the same probability of getting heads versus tails. So, bum, bum, bum. Yes, this is a binomial experiment. It meets the 3 criteria for being a binomial experiment. So now on the last page, we had all those different things we talked about for a binomial experiment. We want to talk about what those things are in this particular situation. Well, first of all, what's our random variable? It's whatever it is we're counting. So this is the number of heads, whatever it is we care about. And little x could take on the values 0 heads out of those 100 flips, 1, 2, 3, all the way up to, yep, all 100 flips could be heads. Not very likely, but theoretically it could happen. What is the probability of success? P is the probability of getting heads, and on a fair coin, that's 0.5. So we can describe this binomial experiment using our notation. X with that squiggle, capital B to say it's binomial. X is a random variable for a binomial experiment, has a binomial distribution. Our n, or number of trials, comes next in the parentheses, and then our p, or probability of success. This is the notation we would use to describe this binomial experiment. Now what we want to find is our expected value. This is the expected number of heads in those 100 flips. You don't need a formula to do this. I'm going to give you a formula, but you don't need it. To figure out how many heads you should get in 100 flips when there's a 50% chance of getting heads, well, it's going to be 100 times 0.5. If we flip a coin 100 times and it's a fair coin, we expect half of our flips to be heads. Now this sigma, the standard deviation, this one you might want the formula for, NPQ. So square root of N is 100, P is 0.5. Now remember, P plus Q equals 1. So if P is 0.5, Q is going to be 1 minus 0.5, or also 0.5. Now, in my face-to-face class, I seem to have a little bit of trouble with doing this in the calculator. So let me see if I can pull up my calculator real quick. I'm going to share my application. I have, where'd it go? There it is. Okay, so here's my calculator. And I want to go to the main screen. So second mode quits me out to the main screen. Clear all that mess I have there. I want to find the square root of 100 times 0.5 times 0.5. So you can see the square root button here. It's on the same button as x squared, but it's blue. So I hit my blue button and then x squared to give me the square root. And then I just go ahead and I type in 100. There's my times on the far right. 0.5 times 0.5. And then for these calculators, you need to arrow out of your square root or whatever it is you're in. So I come up here to my arrow, type that, and you can see my cursor is no longer bouncing around inside that square root, and hit enter. And the answer is 5. So my standard deviation is 5. My standard deviation for this is equal to 5 heads. So these are all of the bits and pieces we talked about on the last page. And now the last part is notation for the probability that we have, what was it? Fewer than 10 heads. Or 12, sorry, fewer than 12 heads. And our notation for that is a capital P, a little x for values of our random variable, and we want values that are less than 12. So again, that will become important when we start playing around with how to use our calculator to make this happen. Now I'm going to go ahead and stop this video here as soon as I can find my recorder, and then I'll start up the rest of the lecture in another video.